Hi gents, we're going to go on to 4D now, which is to do with currents and rivers, and I think wind is in there as well, but we'll start off with just rivers and currents and things like that. There's a bit of conceptual difficulty with this, so you want to definitely have a little look at page 57. They've got the first example. It's a good idea, but I'll try to look at those misconceptions as we go along here. Just to take that very first example, what we're told is that there's a river stream. This is 4D question 1. A straight river is flowing at 1 meters per second parallel to its banks. A boat heads straight out across at 2 meters per second. The river is 40 meters wide. So we know that that length there is 40 meters. Okay, how this works, and very much not to scale, is if we just head straight across, the boat is going to go 2 meters, but at the same time, it's going to get swept 1 meter in that direction. So actually, after 1 second, the boat is going to be there. Okay. If you allow things continue on, what would happen again is if you allow another second to occur, what will occur is the boat will go 2 meters, but be swept down 1 meter. And so it's going to be there in 2 seconds. So there's I suppose a few ways really to think about this. We'll say that length there would be 2 meters. After 2 seconds, that length there will be 4 meters, and so on and so forth. A couple of ways, I suppose, to think about it. One is that this line here, we would call that VB. Okay, so that is what the boat is actually doing. Whereas up here, you might say at 1 meter, this is VOR. Okay, that's what the river is doing. So we can think of this maybe the whole way, think of that the whole way. This is very much not to scale. And this thing here would actually be what is the boat doing in relation to the river. Because it's very easy to think that this one is VB, but that's not actually what the boat is going to be doing. The boat is going to be trying to head across, but it is actually going to be swept along. So it's actually going to be tracking that path. So that's what VB really is. So in this case, if you wanted to think about it, you could say that VB is equal to, so how many I's, how many J's? So it's easier to think of the J's first actually here. So every second it's going to go up 2J, but it's also going to be swept along. So it'll be 1I plus 2J like that. So that's what the boat is going to be. And what we want to know as well is we want to know how many seconds is it going to take. So actually the only thing, you might misconceive of like getting what this speed is and then doing something there, but actually what we really just want is when have we crossed the river? We've crossed it when J is 40. Okay, when the J's are 40. And if it's doing this every single second, you can clearly see that in order to make it to 40J, that's going to take 20 seconds. Okay, and also, of course, it's being swept across 1 for every single second. So if it takes 20 seconds, it's going to be swept across by 20, which actually answers both things. This is what it will be when it has crossed. So we will know, let's do it by our little triangle. We know that the time taken is equal to the distance divided by speed. If we're only interested in what it is going up the way, if you like, in order to cross. So the distance that we've got to cross is 40, and it was going up 2 meters every second. So that's 20 seconds. We also know it's being swept downstream by 1 meter every second. So, well, that's the answer to part 1, 20 seconds. Part 2 is how far downstream will it be? It'll be 20 meters downstream, because it goes 1 every single second. So that's your answer to question 1. It's nice and straightforward, nothing too difficult there, although it's definitely worth seeing just to get a handle on it. Question 4 now. This is a really good question because there are two real ways of getting across this, which they are likely to ask. So we're just going to look at both of these things here. We'll look at both of them. So one way that you could go across is this. If you're the boat, what you can do is you can just try to steam across. That's not what's actually going to happen. Okay, but if you just like head at right angles, you head straight out, what's going to happen is for every, let's look at what the question says, yeah, for every 1.3 meters you go up, you're going to be swept down 0.5 meters. Now, of course, I'm not saying that the river is 1.3 meters wide. I'm just saying this is the ratio. So actually, that's what's going to happen to you if you just go and take off in a boat straight across. Okay, you'll actually end up going at that particular direction there. Okay, that is the fastest way to get across. Okay, that is the fastest way to get across, but as you can see, it's not the shortest distance. The shortest distance would be if the boat actually went along that track there. And to actually go along that track there, what you really need to do is you need to turn into the current. Okay, you need to head off in that direction. And what the current will do is you'll go in that direction and the current will sweep you to there. So you'll actually end up going in a straight line if you take off at a particular angle. So this is a little bit counterintuitive because normally we think, well, if you go the shortest route, you'll get there in the fastest time. But that is not the case here. Okay, it's not the case here. In order to do the fastest time, what you do is you just head straight across. And you know what? We'll actually see that as we do the numbers here along with it. So let's go straight across. You can just compare what's going to happen between the two. Okay, we'll go straight across. Now we're told in this case that it is 39 meters from there to there. Okay, and what we know is going to happen is we're actually going to end up doing this. Now think about it here. After 1 second, okay, after 1 second, what we will have done is we will have gone up 1.3 and we'll have been swept 0.5. So after 1 second, this is actually where we are. 1 second. So after 1 second, we've really moved up. It's still up 1.3. And after 2 seconds, we will again go up a further 1.3 and we'll have moved out 0.5 again. So if we do a little notch on it, we're actually now at 2.6 and we've been swept across 1. So you just think of it like that. But here's what the point is. We have to make it to 39 and we're going up by 1.3 every second. So that is just the same as before. The time taken is going to be distance traveled in an upward direction 39, divided by what we're doing each second. And what we're doing each second is 1.3. So we will have to figure out what that is. 39 divided by 1.3, of course, 30 seconds. That's 30 seconds. Okay, that's doing what? That is actually pointing your boat at right angles as if to go straight across. You will instead get swept down there, so you'll end up actually landing over here, but it will take 30 seconds for that to happen, as we've just shown there, because we're just going up by 1.3 each time. If instead we want to do this in the shortest distance possible, okay, shortest distance possible, this is what we're going to have to do. What we want to do now, whereas before it's kind of worth seeing the one beforehand. So if you just head straight up, you actually end up getting swept down. So in this case, what you want to do is you want to point your boat over here such that it'll go 1.3 along here. Let's say that's 1.3, very much not to scale. But what's going to happen is it's then going to get swept down 0.5. and we want that such that we are going now at right angles. That will get us the shortest possible distance in order for that to happen. Okay, so that's actually what we're looking to do. We're looking to do this sort of direction here. So if we just take that little triangle out there, what we'll see is if we head 1.3 meters per second in that direction, and if we get swept 0.5 in that direction, the question is, what are we actually doing going across the way? As in, if we are just headed straight up, because that is where we will end up after 1 second. So the question is, after 1 second, what distance have we gone from the shoreline? So it's Pythagoras' theorem that we're going to use here, and we're going to say that 0.5 squared plus x squared is equal to 1.3 squared. So we'll just figure out what that is. 1.3 squared should know my times tables. It's going to be 1.69, I think. 1.3 squared, yeah. 0.69, this is 0.25 plus x squared. So x squared minus the 0.25 is, calculator is saying 36 over 25, and when we square root that, it means that it's going to be 6/5 or 1.2, depending on what you want to call it. So what it will really be doing is it'll be doing 1.2 meters up each second. Okay, 1.2 meters up each second. Contrast that with when we just took off. When we just took off, we end up here after 1 second, just at that point there. But we will still have gone up 1.3 in a second, whereas here we'll have only gone up 1.2 meters every second. Okay, it is of course a faster route. You know, you're going at right angles across, whereas here you're going in that direction. It's not at right angles at all, so it's definitely a longer distance that you're doing. But this one here will be a shorter distance, but the time will be longer. Okay. Why? Because what do we have to do? We have to go 39 meters, but this time we're only going up by 1.2 meters every single second. So it'll be 39 divided by 1.2. And that, unsurprisingly, comes out to be more than 30. It's 32.5 seconds. Okay. So that's a little bit tricky. You do have to think about that differently to how you might think about that normally. Your intuition can be fooled on this, is what I would say for it. So what I'm going to suggest that you do is, ones that are like it. We'll say page 58. Again, question 3 is very like this one that I've just done. This one's question 4. So try question 3. It's just the same. So these are my suggestions. Try question 3 and question 5. That will mean that you definitely know what you're doing, I would think. Do we want to try anything else? I would say, just hold it there. Question 3, question 5, question 6 is just the same. So this is what I'll suggest. I'll just suggest if you guys do those 2 there, and I will then do more complicated ones, do an example or 2 and get you to those as well. Okay, gents, all the best. Bye now.